X-ray photoelectron spectroscopy. The following is a brief introduction and setting of the photoelectron spectrometer. X-ray photoelectron spectroscopy produces the electronic information of the inner shell of the sample through incident the energy of about 1000 electron volts light on the surface of the sample, so that we can get the bond relationship on the surface of the sample and the relative quantitative data of the sample. In the same mode, through the incident of a light source with less energy, the electronic information of the surface shell of the sample can be obtained, that is, the element price band information, and the work function change of the element can be understood. In addition, the photoelectron spectrometer in this laboratory is equipped with an AR ion gun, so that we can bombard the surface of the sample through ions. Remove the elements on the surface of the sample layer by layer, and then obtain the depth information of the sample. Precautions before measurement. XPS is a high vacuum machine, which is used to measure the chemical bonds on the surface of the sample and the relative quantitative analysis of elements. Before measuring, the following matters should be paid attention to. First of all, gloves should be worn from time to time during sample preparation and machine operation to avoid the oil residue on the sample or loading table on the hand. The tweezers, platforms and other tools used need to be cleaned before and after using to avoid pollution and damage caused by the residue of the previous sample. The sample should be stored in an appropriate environment and pumped into vacuum to avoid the external environment reacts with the surface of the sample when waiting for measurement. For samples to be measured, please do not use chain bags, plastic bags, etc. to package. During the delivery process, it is easy to touch the surface of the sample to the packaging. The double-sided tape should not be used to fix the sample. It is best to paste it with copper or carbon tape to avoid the sample shaking and falling off. Preparation of samples with substrates. First, the stage and mask should be cleaned. Then, the sample will be placed in the required position, and it will be confirmed that it has been fixed successfully, and the measurement can be carried out. Note that the sample must have a certain conductivity when performing XPS/UPS measurement. If the conductivity is not good, it is easy to cause charge accumulation during measurement. Therefore, this laboratory machine is equipped with an electron neutralization gun to avoid such problems. In addition, this laboratory machine can use the following two sizes of carriers, and they correspond to different measurement items. The following is a brief introduction to the preparation steps of powder samples. The following are the tools that will be used in preparation for powder sample. Indium foil is used in this laboratory to adhere to powder and ensure that the samples have good conductivity. First of all, ingots are pressed to fix and stick the powder to the metal sheet. During the ingot pressing process, it is necessary to confirm whether the metal sheet is flat to avoid uneven charge accumulation. Then dip the appropriate powder on the metal sheet and cover the powder evenly with a pressure. This step needs to be repeated many times to avoid that the powder is not uniform enough, or the amount of powder is not enough to lead to the wrong measurement results. After pressing the powder, put the metal sheet upright and tap on the table to remove the excess powder and confirm whether the powder has successfully adhered to the metal sheet. Finally, use a nitrogen air gun to blow the surface of the sample with a smaller air pressure to blow away the excess powder and the powder with poor adhesion, so as to reduce the damage of the powder to the vacuum state of the main chamber. After completion, the powder sample will be finished. Introduction to pre-measurement settings. In order to reduce the collision of photoelectrons with other atoms in the atmosphere during the escape path, which occur random interaction, result in photoelectron energy loss, and make errors in the final measurement results. The measurement will be carried out in a high vacuum environment, which can greatly reduce the impact of the external environment. Because the main chamber is a high vacuum environment, the sample needs to be roughly pumped in the outer chamber before entering the main chamber, which is a transition area between the main chamber and the external pressure, and make the main chamber can be maintained at a certain pressure even if the sample is in and out. Intro chamber can also reduce the moisture of the sample and the particles are cleaned from the sample. After entering the chamber, you can start to set the required measurement position. If it is a film sample, it is recommended to measure the position close to the center of the sample. In addition, due to the high surface sensitivity of the photoelectron spectroscopy, height difference of the sample surface may affect the information collected. Therefore, it is necessary to correct the z-align of each point. In addition to making sure that the light spot is correctly hit in the desired position, it can also ensure that the photoelectrons with the highest intensity is measured. XPS measurement setup. When performing XPS measurement, if the user does not inform, the operator will scan survey, carbon 1s and oxygen 1s region. XPS measurement mainly needs to consider the following three values. First of all, for the samples, the user needs to predict the obtained results, select the elements to be measured, and set the energy range to be measured. Then, according to the results of the test scan, different sweep numbers can be adjusted, and the data in the same area can be integrated according to the number of times set by the user to obtain a relatively smooth spectrum. However, as the number of integrations increases, the required measurement time will also increase. In addition, the detector can be adjusted with different pass energy, so that the detector can screen and calculate photoelectrons with different kinetic energies. By reducing the pass energy, information with higher energy resolution can be obtained. However, it also decreases the amount of photoelectrons passing through the detector, so that the resulting signal intensity decreases. If you want to obtain a spectrum with a higher resolution, you can also set the number of points to be measured in the same area by adjusting the EV step. When the number of steps is smaller, the number of points to be measured in the same area is more, which correspond to the measurement time for every point will be lengthened. UPS measurement settings. Before starting the UPS measurement, the user needs to confirm the measurement position of the sample, and rotate the stage so that the surface of the sample is perpendicular to the light source. The machine in this laboratory is equipped with helium-1 and helium-2 light sources. Through ultraviolet photoelectron spectroscopy, the work function and valence band information of thin films of conductors and semiconductors can be obtained. Since follow-up calculations are required relative to the Fermi level of the machine, therefore, the sample substrate must be a conductive material to ensure that the sample can be grounded to the stage to avoid charging problems and thus produce erroneous results. In addition, in order to improve the conductive effect of the sample, conductive tape is often used to paste the front and back of the sample, which will inevitably damage the sample to be tested. The user must have an understanding of this. Moreover, user need to pay attention to one thing, that the depth of IOF ultraviolet light is shallow. As a result, the thickness of the material on the upper layer of the sample must be less than 3 to 5 nanometers. And the surface must be uniform and flat to ensure that the information obtained comes from the material itself. The machine in the lab will apply -5 bias to the sample during the measurement, and the data obtained must add 5 electron volts to the x-axis after the measurement. Usually, the results of UPS will contain 2 spectrums. One is the spectrum of the valence band and secondary electron cutoff. Because the intensity of secondary electron cutoff is extremely strong, so an additional spectrum of the onset region will be fine-scanned. The numerical information of the work function and valence band of the sample can be obtained by the spectrum. Depth profile. By bombarding the surface of the sample with an ion gun, the surface elements can be removed layer by layer. After bombarding for a certain period of time, the XPS measurement is carried out, and the depth profiling of the sample surface can be obtained by the information of each layer. The ion bombardment can be adjusted through different accelerating voltages. The size of the energy and the range of the removal area can be changed through the regulation of the accelerating voltage. Moreover, the removal rate of the material for specific energy ions can also be deduced with the results of XPS measurement. The surface of the sample bombarded by the ion gun will cause irreversible damage. The user must have a certain understanding of this. The above is a brief description and introduction of the X-ray photoelectron spectroscopy in this laboratory. Thank you for watching.